everyone, this is Shalini Mittal from Tech Gatha, and this video we will cover binary search. Binary search means means divide into two. For binary search, we have to search for an element if it exists in the array. Binary search has certain conditions. 1. The element needs to be sorted. If your element is not sorted in the array, you can use bubble sort or selection sort. We have discussed the sorting algorithms in the previous videos. The link for the same is provided in the description for you to refer. I have assumed that my array is sorted. So 10, 12, 20 and so on. First condition, the element needs to be sorted. Second is, every time you divide the array into halves. Okay, now what does this means, dividing the array? Let's understand the binary search implementation. Say for example, you have to search for an element. So we'll say search for an element, say 85. How many elements are there? 0 to 6, that is 7 elements. Binary search says divide the element into 2 and look up for. So for example, 85. We'll divide this element into 2. So we'll divide in half, and we'll figure out if this element is in the second half or in the first half. If it is in the first half, then again the first half has to be divided into 2, and then again go on and divide the array into 2 unless and until you get the element if it exists in the array. I know it's a bit confusing, so don't worry about it. We'll see how we do it in Java. Now we have to search for this element. As binary search says, you have to divide the array into 2. How do you divide the array into 2? You will be taking, say, a variable L initialized to the first element's index, that is 0. I'll have H, which is initialized to the last element's index. Now we don't know how many elements are there, so we can definitely say a dot length, which gives me 7 minus 1. So my H in this case becomes 6. I want to divide in 2. So I'll have M, which will be L plus H divided by 2. So L is 0, H is 6. 0 plus 6, that is 6, divided by 2 gives me 3. So my M is 3. That means I am at the middle element. I'll compare if the element to be searched is equal to the element at the middle index. So again you'll write the code. So I'll say if the element to be searched, if the element to be searched is equal to the element at the middle index. Is it 85 is equal to at 3? No. We'll wait. Again we'll search. If S is the element to be searched is less than the value at M. So search is 85. Is it less than this? No. We'll do nothing. Again we say else if value to be searched is greater than the value at M. Is it? Yes. That means now I have to look up for this element in the second half and ignore the first half. So my L, so this has to change to 4. So you will be saying your L becomes M plus 1. Now your L is M plus 1. So this changes to 4. Your H remains as it is, that is 6. We go ahead. Again we divide L plus H by 2. Now this time this is 6, but now this time L plus H, that is 4 plus 6, that is 10 divided by 2. It gives me what? It gives me 5. Again we'll check if the element to be searched, that is 85, is present at the index M. Yes. I'll say, or I can just have a flag the way we had in linear search, initialized to 0, and this is going to continue in a loop, so definitely we'll have a break. Now assume that the element that we wanted to search was 10. So let's go ahead and see. My L was initialized to 0. 0 plus 6 by 2, right? That is 6 by 2, which gave me 3. 3, no, I come here. If the element to be searched is less than the value at index M, true. In that case, I have to search in this part of array. So my H changes to m minus 1. So what is m? 3. 3 minus 1, that is now h becomes 2. So now my h changes from 6 to 2 and my L becomes 0. Now I want to search within this block of element, right? 0 plus 2 is 2. 2 divided by 2 becomes 1. If the element to be searched is equal, no. If the element to be searched is less than this, yes. Again your h becomes m minus 1. M minus 1 means 1 minus 1, that is 0. So your h becomes 0. Now again we'll come here. 0 plus 0. 0 divided by 2 gives you 0. Element to be searched. Is it equal to element at m? True. Yes. Flag is 1. You have to stop iterating. So that means you have to continue doing all these things till the time your L is less than or equal to h, right? The moment L becomes higher than h or it is higher than h, in that case we have to stop. So the conditions will be, we'll just have all these things inside the loop saying while L less than equal to h, continue doing this. And your L will be initialized to 0 and h will be initialized to a dot length minus 1, which in our case comes to 6. These steps just repeat. It goes on. It finds the middle element. It searches. Of course, this has to be in a curly braces because there are two statements. Again, it goes here, changes h or changes L depending on whether the element to be searched is less than, greater than, or if it is equal, then the flag is 1. We'll also have a variable flag which will be equal to 0. So if the element found, the flag becomes 1, otherwise the flag remains 0, and then we'll just check if flag is 0, that means element not found. If flag is 1, the element is found. So this is how you implement binary search. Let's go ahead and see the implementation in BlueJ. We already discussed what is binary search. Let's see the implementation of the same. Again the same stuff, scanner object, initialized an array. I ask the user to enter the elements, displaying the elements, and then I'm asking the user to enter the element to be searched. Again remember, we had a flag initialized to 0, we had a lower index initialized to 0 and a higher index initialized to a dot length minus 1. We are going to have a loop wherein we are going to execute while L is less than equal to h. If it is yes, I'll have to find the middle value. The syntax was L plus h divided by 2. Then we have to check if the value to be searched is equal to the element at index m. Yes, we found. That means we have to change the value of flag to 1 and break this. Else, we'll compare if the element to be searched is less than the value at index m. Yes, if it is less than, then we have to change the h to m minus 1. Else, so if it is less, we have to go to the first array, first half of the array. If the element to be searched is greater, so we will have to go to the second half of the array. So we'll have to change the L. That's it. And then the same code as in linear search. So we'll say if flag equal to 0, else we'll say element found. So let's go ahead, compile and execute and see. Let's enter the elements. Remember, for binary search, the elements have to be sorted, otherwise it won't be able to implement it. So we'll enter the elements in a sorted mechanism, assuming it's sorted. The element to be searched, say 9, element found. Let's go ahead and again execute and say I want to search the element 100. It says element not found. So this is how you implement binary search. I hope you enjoyed. So happy learning, take care and bye-bye.